It is finally time to start containers. Just to do the short recap, let me pull one specific, very complicated and very powerful image called Hello World. And I want to pull it just to show you how it will behave when I do this in different ways. So I have my image downloaded right here locally on my disk. It is Hello World, and in order to run this container, I run the command docker run Hello World. And this message here is generated inside Docker and sent to the standard output inside the Docker, which is in this case underlying host and this terminal. So this is it, right? So I have it. I run my first container successfully. What will be the difference when I try to run the container where I don't have image locally? Let's try this. I will remove Hello World from my computer here. I can't. Why? Well, there is an answer. There is a conflict. I cannot remove the repository reference, which is this Hello World image. I must force it, honestly, if I want to. Don't do that. Don't recommend that. I don't recommend that at this point. And the reason of this is that the container is using its referenced image. But what container, right? What happens here? I run the container, output was printed, and the container just quits, right? I can prove it. There is a command, docker ps, right? So processes, docker processes. Let's clear the screen. Docker ps. There is nothing, right? Docker ps shows you all running containers, but there is a hint. If I use docker ps -a, what means all, right? Voila. I have this container. I have this container with specific status exited, okay? And also I know how long time ago and what was the exit code. 0 means that everything was successfully done. So I have this container still in my system. I mean, not as a running container, okay? But I have the reference to this container. So what I have to do now is to remove this container. How to do it? Do you remember how we remove the images? RMI, right? And now by using the Vulkan logic, we can suppose that this will be docker rm. See? Remove image, remove container. No, just rm. And I will just use this ID of this container. So let's remove it. And as we can see, we removed this container. Now, before we go further, let's stay for a second here. What we have here. So we have the ID of the container, right? We have the image from which we run this container. What command was executed. For now, this is enough what we need to know. I will go there in the separate episode because this is a very important element and very often misunderstood by many people who are using Docker. How long time ago it was created and what is the status, what ports are exposed. We will come back to this in even more future video. And what is the name of this container? This name of the container is like a logical name ID of the container. So we have the container ID here, and this is the container name. And Docker is doing funny thing because it has some list of words and combine two words together. So that's why we have dazzling Newton. We'll see what it will be in the next time we will run another container. Okay, so I remove the container and now probably I am able to remove the image. Yes, I am. All right, so let's clear. So now let's run the Docker container without having image locally. Okay, so what we will do is docker run hello world. Here we can see unable to find image hello world latest locally. As I mentioned in the previous videos, if I do not use any tag here with docker run, docker pull, whatever, it will be latest always. Okay, please remember that. Second element, the image is not here. That's why I'm pulling this image from the Docker Hub in this case. Pull is complete and the container is executed. Okay, in this case, I repeat this again. The function of this container is to start, run this output or print this message to the output and exit. And if I run this container again, you see, I didn't have any information about pulling because this image was already pulled. So I have the image stored locally. Yes, I have. I don't have any container run right now. However, if I run docker ps-a, I will see two containers here, right? Let me make this a little bit wider. So as you can see, I have two containers with different IDs, with different created time and the same exit status really, and with different names. Both are eloquent. Okay. Right, so I have these two containers. In the second part of this video, we will use another image. So let's execute it. It is called busybox. So this command, what will happen after I run it? It will pull the image. Of course, it will check if I have image locally, which I'm not, right? It will pull the image and execute the busybox container. Let's try it. Yes, I cannot find, or Docker cannot find busybox latest locally. That's why it is pulling it from Docker Hub. New image was downloaded. And what happened? Let's try to see. No. Nothing. But hey, I have it here. So what happened? Well, I executed the busybox image as a container with command sh. So sh was executed. Nothing happened there, of course. I will not go deeper into Linux stuff, but just believe me. And the container exited with status 0, as it should. Okay? So this time, let's try to figure it out, what we can do, and we will write something like that. Run busybox. And this time, I will provide the command. So let it be echo, and inside it will be hello from container. And here it is, right? So container started. It took this echo hello from container sentence and command, executed it, and just quit, right? So let's see docker ps-a. You see, here we have this information. There is no sh anymore, it is echo. What will happen if I run something like busybox but with something ridiculous? I can't do it. Oh, well, it was executed to some point, and if I do docker ps-a, you will see that this container is created but not executed, right? So this container was created. Execution was aborted because the command is ridiculous, not recognizable by the system. Is this useful at all? I mean, in some cases, yes. You have some workload where you execute the container, this workload is executed, container quits. That's fine. But first of all, we don't want to have this stuff here, like staying. If I execute the container, I want to quit, okay? And I want to remove this container. Is this possible? Yes, it is. So let's run this busybox echo hello from the container once again, but this time I will add the parameter --rm. What means exactly remove. And please remember, this is the positional parameter and it needs to be after docker run and for sure before the name of the image you want to run. One, and let's run it second time. And now if I do docker ps-a, you see nothing changed from the previous list because one more step was added, okay? Docker checked if I have image locally. If not, it will pull the image from the registry. Docker executes the container, create the container from the image and so on, quits, and removes this image. Now, interesting thing is that I have this jovial, snowy, eloquent, something. Can I have my own name? Of course I can. So let's run again this hello from container without --rm but with --name, and I will call it my container. Very creatively. Okay, and docker ps-a will show me I have this name here. Perfect, right? So let's run this again. Oh, I can't. Why? Because the container with this name is already created. So I need or remove this container or rename this container or execute my another container with new name. Like this. But still, it's all right. I'm running some container, but how to run the container for longer time, right? We know about microservices architectures, and we know that, for example, web server, when I run web server like Nginx or HTTPD, it doesn't make sense to run it and just exit like it happens just before, right? So first of all, we need to run them a little bit differently. It also depends on the command we have as a startup command. We will come back to this in some episode. But also, we can run any container in, let's call it, interactive mode. So in order to run my busybox, and let's keep it as busybox without echo, I have to add here -i and -t, or simply -it or -it. What it means? Interactive and with terminal. So let's do it. And here I am inside my container. Okay. Who am I? I am root. Now let's exit. And if I do docker ps, of course, I don't have this container anymore. As we can see, it is clever Euclid right now, and it is exited as well. So again, it's not that useful. I will not run manually every single time this container and just have it like in my terminal and what else, right? There is another way. We need to add -d, or we can do -itd. What it means, this d? Detached. It means that when I run this container, I have information about ID of this container, and this container is run without like occupying my terminal. So now if I do docker ps, I can see this container, right? How to connect to this container? This will be another video. How to stop this container? I can do it in two ways. Let me run one instance more. So I have two busyboxes executed and run. I can do docker stop this container. It is stopping right now. And I can do also docker kill the second container. As you can see, kill was quite faster. So if I see docker ps, all is the same. And let me clear the screen. And let's do docker ps -a. They both exited in the same way with status code 137 and so on and so on. Doesn't matter really in this case. What is the difference between docker stop and docker kill? The difference is very significant because docker stop will send to the container, to this command which is executed, well, in fact to the container, seek term signal, but docker kill will send seek kill. All right, what is the difference? Seek term will politely ask the process, hey, can you just stop? In other words, seek term will try to gracefully shut down the program which is running. Seek kill will just go and say, hey, shut up, and just kill the process. That's it. First, you always should try docker stop, or in any way, in any means, send seek term signal to stop your application gracefully, allow your application to finish what this application is doing right now. If this doesn't work, then you send docker kill signal. Okay, so we have a lot of this stuff already. Now, how to remove the images? All of them, for example? Well, similar way like we did with docker images. So first of all, we have this docker ps-a, which is exactly this list. Then we have q, which gives us list of the containers IDs, and we can try stop it now already. But very often, and this is a good practice, we want to remove all containers which are in exited state. Okay, how to do it? We need to use a filter status equal exited, and let's see how many containers we have now. As you can see, we have shorter list. There is no 6b and c4. Oh no, there are. So let me So with this, let's remove this quiet to see what we have, right? We have only the exited. So let's bring back our queue. Of course, we can do this. And now we will feed the command docker remove docker. It will be good to use proper commands. As we can see, we have only one left, which is in status created. The status means that this container was never executed. Let's remove this as well. So this concludes our lesson about running containers. So we can run containers and remove it. So already we learned how to install, properly configure Docker, how to pull and remove images, and how to start and execute the container. What we will learn next time? Well, we will see how to, in fact, enter inside the container. So stay tuned and see you next time. Please like, comment, subscribe, because I really need that. See you.